Okay, alright, I wanted to show you guys something really cool. How to make threads in SketchUp based off of standards. There's two ways of doing it, but right now I'm just going to show a really simple way. It will make decent enough threads to 3D print, and they'll be pretty accurate. And it's using the scale tool. Now, I cannot take credit for this. Someone else showed it to me. I think his name was Cinema Tablet on YouTube. And I saw it a few years ago, thought it was a great idea, and I've just never done it this way, but I'm going to show you how to do it. However, the only difference between my video and his is I'm going to show you how to get the threads to ANSI standards and the math involved. It's actually really simple. It's just a basic division and multiplication. So the first thing that you're going to want to do is go to Window Extension Warehouse, and you want to download an extension called Shapes. I'll just show you what it looks like real quick. So it's literally just called Shapes, and it looks like a golf ball right here. It's the one you want. Now, when it's all done installing, you're going to have this thing that says Draw. You're going to go to Draw, and you're going to go to 3D Shapes, and you're going to go to Helix. Now it's going to ask for all this information and things that you're going to have, you may or may not know. Start radius, start angle, end radius, pitch, segments. So the start radius is how far it's going from the origin out. End radius is the same, so with threads you want them to be the same. Start angle is what angle is it going to start from the red axis. 0 is what we want. The pitch is how far apart each helix is. Segments per rotation is, I always set it at 48, that keeps it even, and the number of rotations will be 10. But where does the pitch and these numbers come from? Well, I'm glad you asked. If you go to a web browser and go to AIMS Web, or AMS Web, sorry, .info, you can go to the actual address is right here, and you can actually go to the metric thread size and tolerance calculator. So here's a picture of how threads actually work. It's like a screw is on its side right here. You have all these dimensions. You have 5 times h divided by 8. You have p divided by 8, where p is our pitch. This is our major and minor diameters. Major diameter from peak to peak, from one side to the other, or minor from trough to trough. And h is what we call our fundamental triangle height. So, how do we get the numbers? These letters associate with numbers, so how do we get those numbers? Go to the screw you want to model. I'm going to model an M6. Click it, you hit calculate right here, and then the results will display right here. Now these are the tolerances. This is more information, but the ones we want is just basic dimensions. So we want, here's our major diameter of 6, which 3 for radius. Here's our height. And then the other important one is right here, P as 1, our pitch. That's why I have it set to 1 meter. Now remember, I model big, and then I'll scale down at the end. So let's go ahead and get started. So we need to remember this number, 4.917. Okay. Alright. So now 3, 3, 1, 48. Hit OK. Dang it. I lied. Don't hit OK. I forgot to 10. Okay. Perfect. Now, the reason why those 48 segments per rotation is so important is because we're going to end up putting a cylinder through the center here, and if they don't match and then we try to mess with the geometry, it screws things up terribly. So first thing you want to do is select the helix, go to Edit, Copy, Edit, Paste in place. And then you're going to hit Q for rotate. You want to rotate the origin along the red axis 180 degrees. Now, I think I've seen the actual Sketchup YouTube channel do something similar to this method. So, now, we'll notice what pitch is from here to here. So that's 1, but now it's a half. And now you're wondering, okay, Well, Matt, you just told me we needed a pitch of 1. Now we've changed it to a half. So what gives? Well, this one right here in the center that I have highlighted is actually going to become this one right here. We're going to squeeze it in, and that's going to become our inner minor diameter. Okay, so I'm going to show you how to do that. But first, you're going to hit C, and you're going to make sure that your sides right here say 48. If they don't, you need to change that to 48. Okay, you need to draw on the blue axis, along the blue axis. Well, in the blue direction, along the red axis, 3 meters. Okay, push pull, and we're going to bring this all the way to the top until it meets the very last helical. Okay, we're almost done. Now we're going to explode, and we're going to explode. I don't know why it always brings that up. It only does that when I'm video recording, so the software is interfering somehow. So notice I have this last one selected. That's what we want. I'm going to hit S for scale. And essentially what we're going to do is grab this handle in the center, and we're going to hit Control so that it's about the center, so it's concentric. And we're going to bring it in. Now watch what happens when we bring it in. Okay? See, it starts making those threads. But you ask, well, how far do we need to take it in? That's an excellent question. So, do you remember that number of the minor diameter, the 4.97? So we have to shrink from 6 meters down to 4.97, and the scale tool is based off of percentages. If you keep it at 1, that's 100%. If you shrink it down to 0.75, you've taken off 25%. So, if you write a basic algebraic equation, 6x is equal to 4.917. Solve for x by dividing that 6 over. You get x is equal to 0.82 roughly. So we need to shrink it down 18%, or just type in the number 0.82. So let's do that again, and we'll verify this at the end to make sure. So grab our handle, hold Control, bring it in, and when it's done thinking, and you see it move in a little bit, and you'll notice at the bottom right hand corner it says red scales. Go ahead and type in 0.82, hit enter. Give it a second to think. Okay, then we're going to spin it around this way, and we need to make sure we do it to the other side about the center. Okay, 0.82, hit enter. Okay, and that's thinking. Okay, perfect. It is now done. So, our threads. What are you doing here, little guy? Okay. Threads are now done, and let's verify it. If we go to camera, parallel projection, we want to go to the front view. Those are our threads. Now, if we look at this triangle right here, okay, it should match what this triangle is if we've done everything correctly. Now I've gone through and dropped an altitude from this pitch to this pitch, and I have verified that this is 60 degrees. So I know it works, but I got dang lucky that I was able to draw that profile. It was tough. The other way to verify is if we go to the bottom. Remember, we drew our circle along the red axis. So if we hit C again, okay, notice what our radius is right there, 2.46. Out of curiosity, what happens when you take 4.917 and divide that diameter by 2 to get a radius? What number do you get? 2.46. So our threads are pretty accurate, and if you want to verify again, just to double check, if you make a group, see along there. Okay, now you're going to go into X-ray, and and you're going to push pull this up. You'll notice how it hits every single inner diameter all the way up. So there you have it. That is two ways to verify that your threads are accurate. So let's go back to perspective, and there you go. Pretty fascinating way of getting accurate threads. So thank you for watching.